I solve multi-step equations using more than one approach. So here we're going to look at several multi-step equations, and this one's kind of done for us algebraically. We're going to look at another approach using algebra tiles, but I kind of drew them on here. And then we're going to try and find a mistake in the last problem. So first we start with -3 times x minus 2 equals 3 times x minus 3 minus x. So we have to use the distributive property to distribute these factors of -3 and 3 across these expressions. So then we can combine like terms and go ahead and solve them for x. So the first thing I do here is I do -3 times x, and that equals -3x. And then I do -3 times the -2, which would be positive, oops. I did this wrong. I made a mistake. I should have done -3 times -2 and gotten positive 6, but I did 3 times 2, got 6, and just left it with the minus. I didn't make it positive. So that's going to change this whole thing. So it looks like I'm going to have to kind of fix this as I go. So 3x plus 6 equals 3x. 3 times x is 3x. 3 times -3 would be -9, so -9. And then this just a minus x. So then I combined 3x and minus x. I got 2x minus 9. This would be -3x plus 6. I added 3x to both sides. That's correct. All right, so I eliminated the x from over here. Ended up with 5x over here. This is where this would just be 6 instead of -6. So then I would do 6 plus 9, and that would end up giving me 15. And 15 divided by 5 wouldn't be x is equal to 3/5, it would be x is equal to 3. So that slight mistake can completely change our answers. We have to be careful when distributing, specifically negatives. All right, now we have that same set of expressions, 3 times x minus 2. So here this is 1x, and these are negative units, so -2, and I did it 3 times. So 3 times x minus 2. And then over here I had 3 times x minus 3. So here's x, here's -3. Again, those are negative units. All right, so I have 3 x's, 3 minus 3, so 3 times x minus 3. And then I also have a minus x at the end because that other side had that minus x. Now to solve this, you kind of combine your like terms automatically. So what I would do is I would look here and I would say, look, I have a 0 pair. You don't really need to distribute once you've represented it. So this x and this -x would be a 0 pair. They cancel out, right? So now I have 2 x's here and 3 x's here. What I can do is, oh wait, I made another mistake. When I was distributing, I have to do it -3 times. So this actually becomes the opposite when I actually distribute it right. So again, I've made a mistake in representing this, which is tricky when you're doing it with the negative symbol, right? So if I'm doing it -3 times, I have to do the opposite of it 3 times, which would be x. So the 3 x's, which would all be negative, and then the 6's end up being positive, which in this case is the black one, so, or the 2 units. So I have to actually do the opposite of that to multiply by -3. Okay, so now I have it represented. Now I can make 0 pairs over here by adding in 3 x's to make 0 pairs, and 3 x's here to give me 5x. These end up being 0 pairs and canceling out. And now I have these -9 units, so what I do is I just add 9 units to both sides. So I put in the positive units. And over here I have 6 so far, so I add in 9 more. And this would be what you would do with algebra tiles. And these are going to cancel out with 0 pairs. Now I'm down to 1, 2, 3, 4, 5x, and I have to split it into equal groups of 5. So I'm going to kind of rearrange this. If you had algebra tiles, it would be much simpler. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 15 over here. I just need to remember that and kind of split them up and count to 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then you would look at just any one of these sections. You have x is equal to 3. All right, now I actually wanted you to find the mistake. So we've made a couple mistakes so far, but this one I intentionally made the mistake. Maybe I was thinking in my head about making mistakes, and that's why I did it. So what is the mistake on this one? Well, when you look at this, you might want to pause the video, just kind of look at the problem, think about it. You have 2 plus 3c equals negative 2 times negative 2c plus 6. So 2 plus 3c is fine here, it didn't change. This got distributed, so when I distribute, negative 2 times negative 2 would be negative times negative positive. 2 times 2 is 4, so it should be 4. Oh, so there's my mistake. And from that point forward, I have to kind of adjust that, right? Literally, the first thing I did was add 4c. Well, in order to actually go and fix this mistake, I could either rework the whole problem all the way through, or I could just change this to subtract 4c, which then changes this from 4c, this cancels out, right? 3c minus 4c ends up becoming negative 1c, so just minus c. Then I do minus 2, that's right, minus 2. So then here I end up with negative c is equal to negative 14, which is going to change my answer because I have to divide by negative 1. So divide by negative 1, divide by negative 1, it becomes c equals 14. So again, you got to watch out for distributing these negatives. That's going to be the most common place we see mistakes. Look out for those. And this is how I can solve multi-step equations using more than one approach. We looked at the algebra tiles and algebraically.